You may have noticed that we talked about 2px and 2py orbitals while we were looking at the visualizations at the Davidson website, and we have not mentioned those at all prior to that. The reason is that those orbitals are actually obtained from the 2p plus 1 and the 2p negative 1 orbitals. Okay? The problem with the 2p plus 1 and 2p negative 1 orbitals is that when you write out the function itself, there's an imaginary number that shows up in the expression for psi. So in this expression down here, for example, for 2p plus 1, this I right here, that's square root of negative 1. That's kind of hard for us to visualize. So as a matter of convenience, it's preferable for us to take combinations of these 2p plus 1 and 2p minus 1 functions. So if you take 2p plus 1, for example, and you subtract 2p negative 1, you'll end up with an expression that doesn't have that I. It's easier to visualize, and that's what the 2px orbital that you saw in the Davidson website is. Okay, so same thing. If you take 2p plus 1 and add that to the 2p negative 1 function, you get what's known as a 2py orbital. Now, the 2p0 orbital is just the same thing as a 2pz orbital. And the name x, y, and z has to do with how they are oriented in space. So let's go back to that Davidson website. Here's a 2px. You'll notice it says right here the m values is plus or minus 1. That's because when you have a 2px orbital, your m quantum number is not well defined. It's a combination actually of two possible quantum number values for quantum number m. Okay, so if you have two, and if you look at your 3D representation here of the boundary surface, you can see your lobes are directed towards the opposite sides of the x-axis. Whereas if you have 2p plus 2pz, then you see here it says here that m is equal to 0. You'll notice that the lobes of your p orbitals are directed towards the z, positive z, and the negative z axis. Now 2py would be, you'll see the lobes are directed towards the y-axis, positive y-axis, and the negative y-axis. So combinations of m equals plus 1 and negative 1, m values of plus 1 and negative 1 lead to 2px and 2py, px and py axis. Now if you're dealing with d orbitals, okay, dz squared, you'll see here is as m equals 0, whereas if you have dzxz, okay, you can see that that's a combination of 3d plus 1 and 3d negative 1. So 3dxz right here, okay, is a combination of orbitals with m equals plus 1 and m equals negative 1. And if you do 3dyz, the other combination would be 3dyz. Okay. And then if you do 3dxy, okay, you can see that that's a linear combination. It's a combination of functions of orbitals with m equals plus 2 and m equals negative 2. And then 3dx squared minus y squared is the other combination of 3D orbitals with m equals plus 2 and m equals negative 2. Okay.